In this lesson, we are going to solve this question I have on the screen. The question says that a manometer is used to measure the pressure in a tank. The fluid used has a specific gravity of 0.85 and the manometer column height is 55 centimeters as shown in the figure below. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within the tank. So that's what the question is asking us to do. So let's look at how you are going to go about this question. Okay, so for us to understand this question well, I'm going to do some illustration here, then after that we solve this question. So I'm going to draw a YouTube manometer here. Okay. And then I'll connect a gas container to it on the other side. And inside the manometer I have mercury, okay, as a manometer fluid. So I have mercury in it. Up to some height. Okay. Then in the container it is filled with gas. Okay, so this is the highest level of the mercury and then this is the lowest level. Okay, so at this point here there will be atmospheric pressure. Okay, and then at this point too there will be pressure due to the gases in the container. Okay, there will be pressure due to the gases in the container. Okay, so now let's do some analysis on this sketch that I have drawn here. So when you consider this container, it is filled with gas. Okay, and then all you want to do is to measure the pressure that this gas is exerting. Okay, you want to measure the pressure of what this gas in the container. Okay, so let's look at how you are going to do this. So this container here contains gas. Okay, and then we know that pressure in gases are uniform. Okay, which means that the pressure at any point in this container is the same throughout. So if I have a point here, and then I have a point here, the pressure at this point here is the same as the pressure at this point here. Okay, so similarly, the pressure at a point here will be the same as the pressure at a point here because pressure is uniform in the container. Okay, so we are going to use this assumption to find a way to calculate the pressure that this gas in the container is exerting. Okay, so we know that in fluids pressure does not vary horizontally. Okay, in fluids pressure does not vary horizontally. So what that means that at point 1 here, okay, and then point 2 here, since they are on the same elevation, pressure at those 2 points will be the same. So in that case, that will mean that P1 will be equal to P2 because they are on the same horizontal level. Okay, you know that in fluids pressure does not vary horizontally, and also you know that the pressure in the gas container is uniform. Okay, the pressure at any point in the container is uniform. So that means that the pressure at this point 1 here will be the pressure due to the gas. Okay, that will be the pressure due to the gas. So let's take note of these two assumptions. Okay, so from here let's look at how you are going to calculate for the pressure that is caused by the gas in the container. Okay, so you know that pressure at point 1 equals pressure at point 2, and then the pressure at point 1 equals the pressure in the gas container. Okay, pressure at point 1 is equal to the pressure that is being exerted by the gas molecules. So when you're able to find P2, then we have found P1. So let's look at how you are going to do this. So looking at P2 here, this is where P2 is. Okay, that is the pressure at point 2. So let's say I want to calculate for the pressure at point 2. How are you going to do this? To calculate for the pressure at point 2, that will be equal to the sum of the pressure due to the fluid column above the point, and then that of what the atmospheric pressure. Because when you consider this point here, okay, there's fluid on it, and then there's atmospheric pressure. So there will be pressure due to the manometric fluid and then atmospheric pressure. So to find the actual pressure acting at this point, we just have to add these two pressures. So the pressure at point 2 will be equal to what? Atmospheric pressure plus the pressure due to the column of fluid above the point. So I'll name that PF. Okay, so now let's focus on this PF here. Let's focus on what? That PF. Okay, we know that pressure equals force over area. Okay, but in this case, the force here will be weight. Okay, so that will be pressure will be equal to what? Weight over what? Area, right? And weight is what? Mass times acceleration due to gravity. So we are going to have mg over what? Area. Okay, and then from this formula, density, okay, density is giving us mass over volume. Okay, this symbol I have here is called the rho. So density is giving us what? Mass over volume. So from here I can have mass to be equal to what? Density times what? Volume. Okay, and also we know that volume equals what? Area times what? Length. Okay, and then I'm going to make the length h, so that will be area times what? H. Okay, so this is what? Volume. So now we can come and do some substitution here. Okay, so let's look at what we are going to do. So from this point, okay, from this point, let's continue. You know that pressure will be equal to what? Mass times acceleration due to gravity over what? Area. But I now know mass to be what? Density times what? Volume. Okay, so that will be what? Density times volume over what? Area. Okay, and we know volume to what? Area times what? Height, right? We know density to what? Area times height. Let's not forget the acceleration due to gravity. So this will be equal to what? Density times what? Acceleration due to gravity times volume, which is what? Area times what? Height, all divided by what? Area. So this is what you have. So at the end, we can cancel out the area. This A will cancel out this A. So we are going to have the pressure to be equal to what? Rho G H. So this is the origin of what? This formula here. So to calculate for the pressure due to the fluid column above point 2, this is the formula that we are going to use. So in that case, that will be the PF that we have here. Okay, so let's continue. Okay, so we are now going to have this formula as P2 equals what? P ATM plus rho GH. Okay, this is what we have now. So you know that what? P1 equals what? P2, and then that will be equal to what? Atmospheric pressure plus rho GH. Okay, so therefore we consider what? The pressure at point 1, which is equal to the pressure in the gas container, is also equal to what? Atmospheric pressure plus what? Rho GH. So this will be the formula that we will use to find the pressure that is exerted by the gas molecules in this container here. So to solve this question, this is all what we need. Okay, so now let's go ahead and then answer the question. Okay, so now since we all have an idea of this question, now let's go ahead and then try it. So we've been given that a manometer is used to measure the pressure in a tank. The fluid used has a specific gravity of 0.85 and the manometer column height is 55 centimeters as shown in the figure below. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within the tank. So let's look at how you are going to do this. So from the question, let's look at the data you've been given. We've been given specific gravity, which is equal to 0.85. Okay, we've been given what the specific gravity of the fluid in the manometer. Okay, and then we've been given the manometer column height h, which is equal to 55 centimeters, and then that will be equal to 0.55 meters. And then we are given the local atmospheric pressure to be what 96 kilopascal, and then we've been asked to determine the pressure in the tank. Okay, the absolute pressure within the tank, which will be the pressure that is exerted by what the gas molecules in this tank here. Okay, and we already know that the pressure in this tank will be uniform, so the pressure at this point here will be the same as the pressure at any point in this container. So all we have to do is to find the pressure at this point here, and then that will be equal to the pressure in the tank. And earlier on we derived a formula, okay, which tells us that the pressure in the tank, that's P, will be equal to what? P ATM plus what? The pressure due to the fluid here, okay, which is due to the fluid in this column here. Okay, and then we know PF to be what? Rho GH, so that will be P will be equal to what? P ATM plus rho GH, where rho is what? Density. Okay, this symbol here is what? This symbol here is what? Density. And then G is what? Acceleration due to gravity, and then H is the height of the manometer fluid. Okay, so that's the formula that you are going to use now. Okay, so from the question we're given atmospheric pressure, so we can substitute that direct into the question, but we don't know the density. Okay, we don't know the density. As for acceleration due to gravity, we know it already. As for the height too, we know it already, but I don't know the density. So how are we going to find the density? So now let's look at how we are going to do this. Okay, so the specific gravity of a fluid is given as what? The density of the substance. Okay, the density of the, let me write this again, given as the density of the substance over the density of what? Water. Okay, so that's what specific gravity. And in this case, you've been given the specific gravity of the manometer fluid, so that's what? 0.85, and then that will be equal to what? The density of the substance over what? Density of water. The standard density of water is given to be 1000 kilogram per meter cube. Okay, it's given to what? 1000 kilogram per what? Meter cube. Okay, so let's take note of this. Okay, so that will be divided by 1000. Okay, so now I want to find the density of what? The substance, which is what? The density of the fluid in the manometer. So that will be the density of the substance will be equal to what? 0.85 times what? 1000. So let's find the value of this. So 0.85 times 1000, that'll give me a value of what? 850. So I'm going to have 850 kilogram per meter cube. Okay, so let me write this here. Kilogram per meter cube. Okay, so now we have all the values that we will need to calculate for the pressure in the gas container. Okay, so let's go ahead and then calculate it. So I'm going to free up some spaces here. Free up this space. Okay, so now let's go ahead and then do the substitution. So from here, I'm going to have P to what? P ATM, which is what? 96 kilopascal. So that's what? 96,000. Okay, that's 96 times what? 10 to the power 3. That'll give me what? The 96,000 plus rho G8. Okay, we know rho to be what? 850. Okay, then times acceleration due to gravity, which is what 9.81, times the height, which is what 0.55 millimeters. Okay, so let's sum up all these values and then see what we get. So first of all, let's do the multiplication first. So I have 850 times 0.55 times what 9.81. So this will give me 4,586.175. Okay, so now let's add it and then see what you get. So 96,000 plus 4,586.175. This will give me a value of what? 100,586.175. Okay, and then over here the unit will be, let me try and then derive the unit. Okay, so that will be Pascal. Okay, that would what? Pascal, but you see the value is very big. Okay, the value is very big, so you are going to multiply by 10 to the power minus 3, so that it will be in what? Kilopascal. So that will be P equals, so I'll multiply this value here by 10 to the power minus 3. So let's do that. When I do that, I'm going to have P to be equal to what? 100.6 kilopascal. Okay, the unit is what? Pascal. So let's take note of this. So this will be the pressure that is exerted by the gas in this container that we have here. So this is all for this video. Thank you very much for watching this video. Please make sure you like and subscribe.